Hello everyone, my name is Li Hao. Welcome to Advent of Code 2020. So Advent of Code 2020 is programming challenge on the Advent calendar in the year 2020, where every day on the calendar we have one programming challenge, and in one day we have two parts, and solving each of the parts you get one gold star. So the aim of this challenge is to get 50 gold star. And that's it. So today we are going to do day 16. Do you know what that means if this is the first time you're watching this video? Means that you are missing out 15 videos that I have done so far. All the links over here, please click them. Go, please. Okay, so anyway, back to the topics. So we are going to look at the calendar and let's look at what is up for us in day 16. Excited? Okay, day 16, let's go. So day 16, ticket translation. Well, as you are walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. Well, however, the train ticket you were given is in a language that you don't understand. You should probably figure out what it says before you get to the train station after the next flight. Well, unfortunately, you can't actually read the words on the ticket. Can, however, understand the numbers. So you figure out that these fields, the tickets must have, and the valid ranges for values in those fields. You collect the rules for ticket fields, the number on your tickets, and the numbers of the nearby tickets in the same train service, right, via the airport security cameras together into a single document you can reference, which is your puzzle input. The rules for ticket fields specify a list of fields that exist somewhere on the tickets and the valid ranges of values for each field. For example, a rule like class 1 to 3, 5 to 7 means that one of the fields in every ticket is named class and can be any value in the range of 1 to 3 or 5 to 7 inclusive. Right? So 3 and 5 are both valid, which means they are inclusive. So each tickets are represented by a single line of common separated values. The values of the numbers on the tickets in order they appear. Every ticket has the same format. For example, consider this ticket. Well, a question mark represents the text in a language you don't understand. The ticket might be represented as a 101, 102, 103, 4, okay, and so forth. Of course, the actual train tickets you're looking at are much more complicated. In that case, you extracted just the numbers in such a way that the first number is always the same specified field, second number is always a different specified field, and so on and so forth. Well, starting by determining which tickets are completely invalid. These are tickets that contains value which aren't valid for any field. Ignore a ticket for now. Well, okay, so for example, we have this as the specifications, your tickets and nearby tickets. So we have 4 over here. Oh, sorry. We have 40, 4, and 50 over here. So it is bold, so it must be in something. And in this case, I feel like it does not match any of these ranges specified so far. So whether tickets contain values that are not valid for any field. So in this example, the values on the first nearby ticket are all valid for at least one field. This is not true for other 3 nearby fields. Values 4, 52, and 12 are not valid. Okay, so we're gonna find the invalid values, which is the ticket scanning error rate. Okay, so we need to scan through and find each of the value that is invalid, and we're gonna find out all invalid values and we're gonna add all of them up. Right, so get our puzzle input. Let's save this and move it to day 16. Code day 16. Okay, so we're gonna read from the file using fs read file sync day 16. Let's take a look at our input. So we're gonna have fields, new line, your tickets, nearby tickets, and a new line ending it. empty line ending it. So properly we will have so gonna line number start with 0, and I'm gonna split this as lines content.split. So first thing first is that we're gonna parse this content over here. So fill, range, or range, right? All of them has range or range. So that would be slightly easier. So gonna use a regex again. Fill, okay, so while lines line number is not equals to a new empty line, number plus plus. Okay, we're gonna match this. So equals to lines line number dot match a regex. So we're gonna start with list of characters, and then we have a colon sign and space, and then followed with 2 digits, like digits and a dash and digits again, or and then digits dash digits, right? And I think that will be it. So we will have 5 matching groups. So the first one would be the field name, and then range A1. Okay, it's gonna call it range A1, A2, and then range A3, B1 and B2. Right. Or rather, this is like, let's name it nicely. So this is range A start, and then this is the range A end, right? So it starts from here and ends from here. So we're gonna store all this in a map, right? So fill rules. I think I call it rules as a map, an object, and then we'll keep it as okay. I think we'll store it as an array of fields, right? Field rules dot push field name, and then probably range. Let's see. I think I'm gonna have 2 ranges, and I say range. The first one is range A start to range A end, right? Range A end. And the second one would be range B start and range B end. Okay. And then line number, and then we pass this all the way. And then the next one is gonna find our ticket. Right, so line number, we are reaching the line with empty, and then we're gonna skip 1, 2. Line number plus 2. Then this line will be our ticket, right? So your my ticket equals to parse ticket. Okay, I don't think we need to parse. It's a number, comma separated number values, right? So line numbers, lines line number dot split by comma, and probably map with number to make it a number. Okay, and then we're gonna I'm gonna start again. 3 more lines later on. Then your tickets, neighboring tickets, will be all this. Right, so probably we're gonna store all of them as well for now. While lines of line number is not empty lines. Then so this, I think we can reuse all this code over here. Let's say parse ticket, takes the string and then returns the string, split comma and map to number. So this will be parse ticket. We'll do over here as well. and I'm gonna push this to the list of tickets we are looking at. And number plus plus. Okay. So now we are going to loop through all the tickets for const ticket of tickets. We'll find any field that does not match any of the range in the fields, right? So and then we're gonna sum all of them, right? The sum will be actually I think it's called the error rate. Error rate starts with 0, and then we're gonna sum it all up. Before that, probably what we can do over here is that we can try to do some optimization in terms of the range, right? Each of the field has 2 range. We have multiple fields, which means multiple of ranges. We can, in this over here, when we have each of the field of the ticket, we can loop through all the fields and then see whether it matches all the ranges, any of the ranges, or we can actually get a list of range, all of the range of the tickets, because we just need to know whether one of it is valid, right? So we get a list of all the ranges, and then probably we merge some of them if they are overlapping and then combine them. Probably that will make it slightly faster. I hope it will be way faster. So so this is what we call it. We can do a pre-processing of the data so that we trade in slightly costly in the beginning to do pre-processing, and in exchange we'll get faster incrementally in the future when we use the pre-processed data to solve our problem, right? So probably I call this variable called as ranges, right? And this is actually field rules flap field, let's see, field rules. Okay, it should be starting with empty array, and for all the field rules, I'm gonna push in the range. Just 0, and I think like this will do, right? And then probably do a sort, right? So range A and range B. So we'll sort based on the beginning of the range, so that starting, so that range, so that in the resulting array, the one that starts earlier comes in front, and then we'll reverse order. If they have the same starting point, then the one that has the highest timing will come first, so that we know if the next one will be within it, we can remove them, right? So so we're gonna return range if the starting is the same, then we're gonna descending order of the range ending time. But if not, then we'll base on ascending order of the starting time. Okay. So once we sort it, we can now use one pass to loop through the list of ranges because they are sorted. As long as the next range that we're looking at is overlapped by the previous one, then we are going to remove them, right? So because we already pre-sorted this, we know that the starting time of the previous one is always less than or equal to the current one. So we just compare the ending time, right? So if the starting time is, so the next range, okay, so I think we have mirror over here. So this is the previous and this is the next, right? So the previous one, if the previous ending time over here is ends less than, is ending before the next one, then they are considered two different range. But if this is ending before, Then we're gonna expand it and then remove this range, right? So that's the idea of merging the ranges. So we're gonna use a variable called, let's see, let range index equals to 0. I think we can start with 1 because the 0 will not be merged at all, right? So while range index less than the range just dot length. So let's see, if range just range index dot or the ending time, ending will be 1, ending time, wait, the current one is like, okay, so the previous one ranges range index, the previous range ending time, if it's greater or equals to the current starting one, which means that it's overlapped already, then we're gonna merge the ending time, index minus 1, 1 equals to math.max. So it could be like this or like this, right? So we're gonna get the max of both ending time. So ranges 1, comma. Okay, so we get a max of the ending time. And this also means that we are going to remove this index 1. So delete 1 item from this index, and that's all. If we are not doing any of that, then probably we're gonna increment range index. Right? So far, I think we have merged all the ranges. So just to be sure, I'm gonna log and see what the ranges we have so far. Before that, I think before we do the merging, we can over here we can look at after the sorting, we can look at how it looks like, and then after we merge and looks at the output. Right, so we're gonna run this day 16. Okay, ranges. I know. Fill rules dot ranges. Fill rule dot ranges. Right. See okay, numbers itself. We need to convert a number, but rough idea you have seen here so far, we actually merge them, right? Just that might not be correct, but let's see. Okay, so this is okay. So what we're gonna do here is we're gonna convert them to number. Let's try that again. Okay, so sorted them and merged them. So you see now, instead of holding multiple ranges, we have only one range. Probably because all of them are overlapped with each other, right? If they are not, then we have more than that. So we get our ranges up. Then next thing is we're gonna go through each of the tickets. So each of the field of the ticket and if okay, and then we look through each of the range of ranges, right? If field, okay, so each of the range has two numbers, right? The start and the end. If the field is so it's within a range and we found it, right? But there might be multiple ranges. As long as we are in one of it, we can actually stay, right? So if the field is within start and field is we can continue, and we actually continue to look through different field, right? So I'm gonna call it field loop, continue this loop. But by the end of it, we still haven't found anything, which means that we didn't match any of the ranges. Then probably this is invalid field. So error rate will plus field, right? And in the end, we're just gonna print out the error rate. Let's run this. Okay, let's clear this first and then let's run this again. 29878, and let's see whether is this the right answer. And it is, right? It is the right answer. And let's, one gold star is down, and let's take a look at part 2. So continue with part 2. Now that you have identified which tickets contain invalid values, discard those tickets entirely. Okay, we're not going to use tickets that are invalid. So remaining valid tickets are determined which field is which. Using a valid range of each field, determine what order fields appear on the tickets. The order is consistent between all tickets. If your seat is in the third field, it is the third field on every ticket, including a ticket. So based on the nearby tickets, the first position must be the row, second position must class, and third. So each of the field, so 3, 15, 5 should belong to either one of the class, row, or seats. 9, 1, 14 are the same field as well, and 8, as well as 18, 5, and 9. Right? So we have to figure out. So there will be only one combination that fulfill this, right? So you don't have. I don't think you will have multiple fields, or one field, one column maps to multiple. No, I think it won't have a case where multiple columns map to the same field, right? So I think it's one-to-one mapping. So we're going to find out all the one-to-one mapping, right? So once you work out which field is which, look at the 6 fields that on your ticket that starts with the word departure. And what do you get if you multiply those 6 values together? Okay, so the first thing is we need to remove invalid tickets. Okay, so we don't need all this. We don't need the error rate. But we need to remove it from the tickets. Right, so I think we can't use this for const loop to loop while modifying the array. So we're gonna convert it to a for index loop for index I equals to tickets dot length I plus plus, or rather we don't do I plus plus. We're gonna come here. Okay, so at the end of it, if we can't find anything that matches, then tickets dot tickets dot splice I at 1, and then we are going to continue the ticket loop. I'm going to continue a ticket loop. And if not, then I plus plus, and then we continue to add 1, right? So if we remove the second ticket, then we splice the tickets array, and then we continue to look at the second ticket again, because that was previously the third ticket, but now it's the second ticket. Right, and let's see, range, continue field loop. Right, as long as it's match 1, okay, continue. Okay, so I think we are done over here. Remove invalid tickets. Then the next thing is that we're gonna find combinations of class of the fields to the column. Right. So what we're gonna do here is that we're gonna have a list of possibilities for each of the columns. Right. So I'm gonna call possibilities. Right, this is actually we'll have all the possibilities, right? So it will be based on the, say, I equals 0. So depends on how many fields that we have, right? So number of fields that we have is actually based on the number of field rules. Okay, so it's field rules dot length. For each field rules length is actually the same as number of columns. I think we renamed this slightly better, which is tickets, first tickets dot length. Right, so it has like, it's actually having the same number of field rules column, but I think writing it this way is more meaningful in terms of what we're trying to express over here. So we're gonna loop through all the different columns of the tickets. And actually what we're doing here is that we're gonna say for each column we have all the possibilities, which is a set of column names. And getting a column name is actually getting a field rules map field name. Right, so each of the possibilities, so we're gonna have if you have 16 fields, then we have 16 possibilities item, and each of them is a set of all the possible fields that it can has right now. And what we're gonna do next is that we're gonna loop through the tickets. I think let's count tickets of tickets. For each of the tickets, and go through the field each of the ticket will go through a field, and for each of the field we're gonna get the possible field name of possibilities field index, and each of the possible field name we are going to see whether okay, so the range for the possible range field rules. Oh, we're gonna find the field that maps. Okay, so probably we're gonna create a map first instead of looping through the field rules and find out the mapping. Right, so field rules map equals to an object, and over here we're gonna for each field name and ranges field rules map field name and equals to ranges. Okay, field rules, we get the field rules map, we get the possible field names, get a range, and okay, so for I think it's called ranges, right? Ranges, and for each of the range of ranges, if okay, so range has the start and an end. Again, if tickets of field index is okay, so if it's one of it, then ticket field index. If it's one of it, then it is possible, right? Then we're gonna continue with the finding, look at different possible and see. So we're gonna yeah, so it is possible, then we continue. But if it's not possible, then we're gonna remove it, right? So this is the possible field name loop. Continue this, but once we reach all the end of ranges, if it's still couldn't find a it still doesn't match any of it, then we're gonna do something over here. I feel like actually we can use one of the built-in JavaScript function that makes this looks slightly easier to read, which is if ranges sum where sum of the range. So we're gonna find if any meets this, then sum will be returned true. If none, it will return false. And so the predicate will be returning this, right? Return this. So if none of it contains, so if we can't find any that matches it, okay. I think this is my habit that if it's one line of return, then I'll probably write it like this without the brackets. So if we can't find any of it that matches this condition, then probably this is not possible, right? So I'm gonna save it first. So I'm gonna have a to remove dot push possible field name. So to remove is a list of so again, like just now, if we want to remove while it's looping, it's not possible. So it's either we change this as index and we control the index, or we have an array that we want to remove. And once we loop through everything, I'm gonna loop through again. Fill of to remove, and then we remove each of them, right? So so you can keep on finding all the things that remove and then remove at one go after the loop, right? So dot delete field name. So I think after all this loops through all the tickets, probably by the end of it, the possibilities is log possibilities. It's left with all the things that is. Let's see what we have over here. Tickets. This is not ticket. Hey, wait, what? Field loop. Oh, okay. Field loop. Tickets I. Okay. Let's go. And okay, so so there are still columns that is possible that still has different possibilities. Oh, I think some of it is less than the other, and probably I might find one that has only one possibilities. Probably I can take my ticket as consideration as well, right? So over here, gonna add one more tickets dot push my ticket. Run this again. Let's see. Do I have less? Feels like not sure how I can remove even more. Let's see. Range continue. Okay, so remove. Okay, so possibilities. Each of the range. Okay, hold on. I think this one, I'm not sure whether it's related, but I'm gonna add it over here instead. Hmm. So remove find all the possible range, and then let me take a drink, take a sip, and let me think about it. Well, I looked through the code a bit, and actually I found out what went wrong actually. So basically over here when we do the sorting out of range and merging of the range, right? What we've done in the process is we are modifying one of the range, and yeah, we are doing it we mutate the range array of one of them, and I think uh, that's why we found out so many valid fields possibilities, right? Because probably one of it encompass most of the range. So to do that, instead of doing this, we are probably gonna loop through the range of ranges. Fill rule dot ranges, and probably we gonna have to do it on our own. Create a new array in the process. So this is a new array. Modifying it's safe, right? So let's run this. Sorry, let me clear. Let me try to run it again. So console up possibility. Let's try to run it. And does it looks better now? Yeah. So you see, there's one of it is only one, only have one possibilities, right? So I think we can work from here where we remove we remove price from everyone else, and probably in the process, and then probably we'll end up with having another column that has only also one possibilities, and do it over and over, and probably in the process we get set for all of only one possibilities, right? So doing that, let's see, what we can do over here is that we can sort the sets array so that the set with only one item comes in the beginning. So we use that and remove all that field names throughout all the sets and go to the next one. Hopefully it's only left with one possibility as well. And then loop through the rest of the array and remove everything that contains that field name. Right, so to do that, probably we can we keep the sets, the index and the set value, right? So possibilities array equals to, okay, so possibilities dot map. So we have the possibility sets, the sets, and index. So we're gonna return possibilities dot equals to that sets, possibilities set, and the index. Okay, so doing this, we can actually sort by the size of the sets. Okay, so this dot size minus b dot positive dot size. Once we've done that, then probably we can look through for let's I equals to 0, I less than possibilities dot length. Okay, so should be the array instead. Array plus plus. Probably with, okay, so for let's j equals to I plus 1, j equals why there's nested loop, because over here with the first thing, probably we'll know that the only item, right? Hopefully this only have one item. So this is called a field name equals to the possibilities array index dot possibility set, and we get the only one item. So dot values and probably 0, right? Hopefully there's only one value, and we remove this field name from all the rest of the possibilities. Dot j dot possibility sets dot delete field name, and we do this over and over again. So hopefully by the end of it, possibilities array console log this out. Hopefully see. Hey, wait, hold on. I still okay. So the first one is only one. Oh, I didn't remove the price. Wait, see what's went wrong over here. I plus 1, j plus plus. Okay, so probably this values is wrong. So let's see, field name. Okay, so dot possibility set dot okay. I think this is an iterable instead of so probably we need to convert it into an array. Array dot from, and yeah, that's so values returns an iterable where we can iterate through using a for loop, or you can using an index to get it. So actually, if we are converting an array, we don't even need to use values. I think like this will work as well, because we can also cast from a set into array, or any iterable to an array. Right. I think after this, probably we already have index mapping with the column name, right? So it's a matter of time where we sort it based on the index, and then we map it to get the column name, right? So possibilities array dot sort. Now we sort based on the index, so it's the a dot index minus b dot index. Then we map to get so each of them has a possibility set. Oops, sorry. This one is this. Okay. To get the value of that set, so it's the same thing over here as well, where we have the array dot from possibility set and the first item of the array. So column names or field names equals this. And then once we get the field names of each of the column, probably we can know what is our ticket. So my ticket object equals, okay, so now we're gonna look through the field for cons field of field names. If so, my ticket object of the field equals to the same index. Okay, so I still need to get an index. I equals 0, I equals field names dot length I plus plus field names I equals to the my ticket, right? It's my ticket I, right? So this give us my ticket, right? And then we need to find out keys that starts with departure, right? According to it, we need to find the t's that starts with fields that start with departure and to get the values and then multiply them together, right? So okay, let me remove this console. So what we do here is that const key value of key value of my ticket object dot entries, get key value pair of it, and if the key dot starts with departure, then we need to multiply the value, right? So let's have a variable called product, starts with 1, because anything multiplied by 1 will be that value, right? Product times equals to, right, value, and console log product, and run, and hopefully this will be the answer. Phew, yes, that's the right answer. And everyone, this is Evernote code day 16. So finally we solved this. If you like this video, give me a thumbs up. If you find anything that you think I can improve on, please comment down below over here. And if you want to know how I'm going to solve day 17 and onwards, all towards to the end of the Advent calendar, subscribe my channel so the next video will pop out in your notifications. So see ya, bye.